If I delete the first one, check the memo list as that and advance it. And then I add one. Oh, it's set up above, right. I just did this work. That could actually, yeah. That didn't need to be in the mutex. Let's just do it at the end. Okay, what did I screw up in my linked list code? If it's, when we add it, we always put it at the head. We forgot to link. Got to create the backlist. All right. What is it doing? Okay. Now what did I forget? Wait, why did it crash on this? Oh, it crashed on this turn. Wait. What? Is my lock not working? Memory mutex is real. Memo head. How do we get in the state? We can just write a free list scanner to figure out how we got in the state. And next is memlist head, memlist head, memlist head. Who's gonna, his back pointer should point to M, and then memlist head is M. Then memlist head. Who's gonna, his back pointer should point to M, and then memlist head is M. I don't know. I don't know what I'm missing here. The agenda is I'm adding memory profiling and performance profiling so that I can figure out what's going on when I start running out of memory and stuff, and why things are running slower than I'd like, certain things. Why does that lie to me about where the assert is? That's not good. I assume it's this assert though still. Prev is null, but memlist head is not M. And yet I've run check mem. Is anybody calling these? Is anybody touching these without? No, I just call OBBG lock and OBBG free. So they should all be guarded. Let's indent that to be clear. I don't think it's, well, I mean, I did screw up the linked list, so I don't think this is linked list so much as multi-threading probably. But I mean, maybe I'm missing something. Brief is not null. Brief next is next. Next is not null. Next brief is brief. Seems right. Always in this. We are making realloc do something it didn't used to do. It's now always Alex. That's not good. I mean, of course it's on the wrong line number. I don't understand why the debugging is broken now. So I don't know why I got that error from the compiler that one time. Should I be paranoid about? Oh, did it rebuild all? What is that? That stuff is all defined in util.c. What happened to util.c? Where did util.c go? Oh, I exited that one time. I bet it didn't save it. Who knows if that had anything to do with it. Oh, I never put up my normal things. Oh, I never put up my normal things. Oops. What did I just grab? How do I ungrab it? Shoot. I just moved something. Alright. Give it up. And what do we actually have then? Yep. Look what needs to be done next. Write a real performance monitor. Write a real memory monitor. Alright. We built. We'll just be back in the same error. No. No, now we had a bad free. We'll just be back in the same error. We built. We built. We'll just be back in the same error. No. No, now we had a bad free. Which probably means somebody tried to OBBG free something they didn't create. No, it's part of the part of the STB array stuff. See, if I still had the guard. Alright, let's just go ahead and misalign things and have the guard. See if the guard catches it. Or I might just be passing the wrong pointer into free in my rewrite. In the OBBG free it would be. Free M. Okay. OBBG free it would be. In the or I might just be passing the wrong pointer into free in my rewrite. In the OBBG free it would be. Free M. Oh, I never put up my normal things. Or I might just be passing the wrong pointer into free. Free M. Okay, so we allocate, and then we return M+1. And then when we free, we take that pointer and move back by 1 to recover our original M and free it. Seems correct to me. And we got all the way by the check mem stuff. We got by that. So it's totally valid. So how's that not the right thing to free? Unless there's still a malloc wrapper somewhere. I don't know. Why would this go wrong? How is that? How are we freeing a different pointer than we allocated? Is realloc doing the right thing? Calls OBBG free before it's subtracted. Remember copy. Incorrect. No, correct. Is the early. Yeah, we can copy between the mem infos. Let's do that in the other order. I don't know what would go wrong. All right, let's. Oh, those did need. Oh, those did need to be inside. That's right. Because we're doing that on multiple threads. That's why that was like that. I think that's redundant. Wait, I never declared these variables. Oh, I did. Okay. All right, so let's see which free this is on. Let's see which free this. All right, so let's see which free this is on. Of course, because it's threaded, it might not be consistent. Oh, those did need to be inside. That's right. Because we're doing that on multiple threads. That's why that was like that. think that's redundant. But wait, I never declared these variables. Oh, I did. Okay. All right, so let's see which feed this is on. Of course, because it's threaded, it might not be consistent. Okay, it's the third free. Second time I hit that. See if that's consistent. Yep, alright. So now let's step in the second time. It's gotta be gross. Alright, so first time, C belts is that. Now when we come back around, it's the same. It didn't let me step into it. Oh, I accidentally stepped over it. Fuck. And I accidentally left a breakpoint in the middle of that thing. Okay, good. It's ignoring it. Oh. Didn't leave that one. Yes, I am the author of the STB libraries. Thank you. Well, or you're welcome, rather. Okay, we do it again. Okay, that one. Yes. Yes, I am the author of the STB libraries. Thank you. Well, or you're welcome, rather. Okay, we do it again. Okay, look down and make sure I'm on the right key. Alright, so what we're looking at is PP is a pointer to an STB array. But it's actually offset by 1. Rather. Okay, we do it again. Okay, rather. Okay, we do it again. Okay, look down and make sure I'm on the right key. All right, so what we're looking at is PP is a pointer to an STB array. But it's actually offset by 1. Okay, so it's an array of 2 items. There's storage for 2. And then before that is the mem info. Which itself is backed by 1. Nope. Didn't like that at all. Wait, was it not called mem info? What was it called? Mem info. Does it not know about the mem info type? What the heck? What? That's no good. Minimalist head. It does know about that type. Well, that sucks. Getting burned by VC6, maybe. I don't know why it won't let me look at that type. Alright, so what was I was looking at? STB, Ray, star PP, -1. And then I want to cast it to a unit 32 star. And subtract 5. And look at 5 values. And I need to double parenthesize that. And comma X. Oh. Alright. So here is my mem info struct. So you can see the guard value is there. Something is uninitialized. What's uninitialized? Info brief guard. I never set the size. That'll be. I never set the size. Info brief guard. Info brief guard. I never set the size. That'll be set. So what's uninitialized? The guard value is there. The guard value is there. Something is uninitialized. What's uninitialized? Info brief guard. I never set the size. That'll be the bug. Because then this mem copy doesn't work. And then who knows what goes wrong. It's certainly a bug. I don't know if it was the bug. Why is my computer slow? Nope, not the bug. God damn it. Why can you not free that? I'm trying to free that. I'm trying to free that. Where did A come from? Came from PP. Alright, so A is that, and then 32 star A -5, comma 5x. 9876542, the size of 24, previous and head, info. It's still not going to let me do it. Yep. Okay, so that looks legit. Okay, we should check that it's in the list. Can't copy. And then if it's not null, then we have to found it. So found. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Uh-huh. Okay, it's claiming it's not found in the list. So dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Okay, we should check that it's in the list. Okay, copy. And then if where it's not null, then we have to found it. So found. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Uh-huh. Okay, it's claiming it's not found in the list. So either there's an existing double free bug, or I don't know what. Am I freeing things twice? I call malloc, and then I call free on the old pointer. And then I return the new pointer. So it should be no way through this path that you would get that. Okay, then here we have a pointer. Back off of it. We realloc. And get a new pointer. I don't see how this double frees. Unless it was always double freeing, and then I still don't see how it double frees. I'm not just calling free twice in here somewhere, am I? Luigi, malloc. Okay, that's it. Gotta return, that's gotta return, that's gotta return. OBG free. What? What? Alright, let's just trace, what's my output routine called? ODS. Let's just trace everything to free. Output routine called? What's my output routine called? ODS. Just trace everything to free. Let's look at their freeze. And what are we bring currently? The one we just printed, that's what we're freeing. So we haven't freed it before. So now we have to see if we've ever allocated it. Can you search in this pane? Never tried to do that before. Hey, look, I never allocated it. All right, so possibly this stuff somewhere is still calling malloc instead of OBJ malloc. I'm calling raw realloc. Don't see it though. And possibly somebody is still calling the STB array push somewhere. Okay, apparently I missed some. Oh no, that's that one. Right. Oh, all right, I don't know. I'm mystified. Where is that pointer coming from? Alright, so we need to work backwards. That was in logistics. So I don't remember where it was. Let me just find it again. All right. So let's just look at the value of belts at various places. Just look at the value of belts at various places. We're creating a belt. Alright, let's see if we see it. Alright, let's see if we see it. Yeah, there's just too much code to actually step through it all. Yeah. Yeah, there's just too much code to actually step through it all. So 3AA3168. Nope. Never allocated. Okay, well, where is that coming from? Come on, equal. It's about refs. Never allocated. Never allocated. Okay, well, where is that coming from? Come on, equal. It's about refs. I think that's different from a belt run. Okay, it looks like it's only ever created implicitly by the push thing. Nobody ever assigns it. I don't know where it gets initialized to null. Nope, I don't see anywhere else. So I assume we don't have a list of all the logistics chunks. We only have the ability to query it through the get chunk. Is there non-allocate get chunk? Yeah, there is. I had a conditional breakpoint in the CRT allocation. I don't know what the allocation is. I had a conditional breakpoint in the CRT allocation. I don't know what the allocation is. It's different every time I run. And I don't know what the allocation number is because it's multi-threaded, and I don't want to go try to disable multi-threading while I'm in the middle of this change, because it doesn't work. Like I have to spend some time getting single-threaded working again. Doesn't look like the Git has been updated in a while. I think it's... Doesn't look like the Git has been updated in a while. I think it's probably up to date. I just haven't done it in a month or whatever. I'll check. Yeah, it doesn't look like there were any changes. I started working on the leak checking last time and it wasn't working yet, so I never checked it in. All right. Almost, but not quite. But wait, those are off by the size of the meminfo thing. Checking last time. Working at any changes. I started working on the leak checking last time and it wasn't working yet, so I never checked it in. Alright. Almost, but not quite. But wait, those are off by the size of the meminfo thing. Which is the same as that. Which sounds like I'm just not doing the memo info offset right or the STB array offset correctly, since they're both. Oh, in fact, memo info is now it's 14 hex, and STB array is 10 hex. So it sounds like it's not doing the STB array offset. So what is A? 6.8. That's the value that was passed in. P. Okay, I'm confused. Oh, there's another P. That's unlucky. Okay, I can look at PP. Okay, that was what was passed in. Then we subtract 10 to pass it to free, which is correct. Okay. So the alloc that I'm looking for needs to be the 7.8, which is that one there. But that's not an alloc one, I don't think. Or maybe it is. Alright, allocs, once you've added the STB array on, it's at 7.8. And then the free is at 6.8. And then M should be 5.8. Or 5.4, right? Yeah, because I changed it when I added the guard. How about that? How about that? How about that? No, it is correct. I do want to assert that it's found. All right, I'm confused. It has to be found. Yeah. Okay. All right, so let's jump back to here. let's step out. How about that? No, it is correct. I do want to start that it's found. Alright, I'm confused. It has to be found. Yeah. Okay. Alright, so let's jump back to here. Alright, let's step out first. Let's go to here. Just want to see if there's a value close but not quite right. That is close but not quite right. Am I passing in the M? I am passing in the M. And the M looks good, right? Yes. Because the one that I'm at right now, that looks like it's exactly before. That looks like a zero length thing. Like, how is that? That one overlaps that. If we take M plus size, it overlaps that. And suspiciously, it's a belt list. So somebody somewhere here is overrunning memory. And I don't know why changing the mallex is causing that. Well, the Git only updates when I stream because I only do development on stream. Well, the Git only updates when I stream because I only do development on stream. So. All right, what am I missing here? Should I back everything out and start over? Oh, here. All right, what am I missing here? Should I back everything out and start over? Oops, not P4 diff. Oh, well, that's not very helpful because it's got a bunch of other stuff in it. All right, there it is. No, I don't think I'm going to learn anything useful from trying to look through this. Is there a more systematic way I can make this change a little bit at a time? All right, let's try this. All right, let's try this. All right. So at this point, what's changed is that I moved the STB array stuff over. But I have no guarantee. All right. So at this point, what's changed is that I moved the STB array stuff over. But I have no guarantee that it's not still trying to use the STB array stuff. Although I searched for it pretty thoroughly, I think. Okay, so now let's do this. All right, seems to be running fine. What that was. So here I'm offsetting everything in a similar way. Now let's change this to do this full logic. If size equals 0, p does not equal null, 3, p minus 4. Return null. Else if p equals null. That shouldn't make any difference because I don't use that path. Alright. Now, let's replace the realloc with the malloc and free. So, IQ equals, well, this won't work for shrinking because I don't know how big the old size is. In fact, it won't, yeah, whatever. Malloc plus 4, then copy store Q plus 4, comma, P, comma, size. So we copy more data than exists in P, which could crash. And then we free star P minus 4. Then we return star Q plus 4. Now if we get lucky, we'll hit the error in the exact same spot now. Nope. Alright. Okay, now we want to replace this with this. So Q equals OBBG malloc. Size info. OBBG free P. like that. All right. Now, did I do the corresponding one wrong here in the mem copy? Q comma M, so I'm copying over the mem info. Which is wrong because I'm copying over the prev and next pointers. I don't want to do that at all. There you go. That's the bug. The mem info. Which is wrong because I'm copying the corresponding one wrong here. Alright. Alright. Now, did I do the corresponding one wrong here in the mem copy? Q comma M, so I'm copying over the mem info. Which is wrong because I'm copying over the prev and next pointers. I don't want to do that at all. There you go. That's the bug. But I do want to copy over the info. And I don't need to set up the guard. Oh, and I copied over the info when I did that. So I don't need to do that at all. So that was the bug, I bet. 0, 0, 0. Alright. Alright. Goddamn. Alright. That looks pretty uninitialized. That looks pretty garbage. Why did we get past garbage in? That looks reasonable. I don't remember what the signature is supposed to be. Something bad is probably correct. What's in the head file? Oh, ends with 123 in decimal. Okay. Yep, okay. So, that looks correct. Yep, okay. Okay. 123 in decimal. Oh, ends with 123 in decimal. Okay. Yep, okay. So, that looks correct. That looks corrupt. How did we end up with a corrupted M? This is why you put this stuff in from the beginning instead of having to hack it in hindsight and have no idea what's going on. I guess I could write a test program for this. Just have main start doing some test stuff before running any of the regular code. There's new threads. It would be all predictable. Yeah, I like A. And A looks good. But the stuff before A looks bad. Which could happen if it were running the STB array stuff, so it didn't get through the wrapper. How else could it happen? Am I sure this is now working correctly? Because I'm no longer memcopying that stuff. Q equals OBBG Malik. It's not Q plus 1 anymore. Dun, 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 dun. It's not Q plus 1 anymore. Malik. Q equals no longer memcopying that stuff correctly. Because I'm no longer. This is now working correct. Am I sure this is now working correctly? Because I'm no longer memcopying that stuff. Q equals OBBG Malik. It's not Q plus 1 anymore. Dun, 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 dun. I can just do this like that. Oh, except I don't have the MR size anymore. Oh no, I do. Okay. Alright. I think that'll be everything. It took forever. Alright. Delete all the debugging. I apologize that was a really uninteresting debugging experience. Now we would be able to look at the stuff. I need to write some software to output info about that now. So it's in util software to software. I need to write some at the stuff. I need to be able to look. Now we would be able to look at the stuff. I need to write some software to output info about that now. So it's in util. So what we want to do is we want to return stats about these strings. I don't really like callbacks very much, but let's just do it with a callback. Void OBBG Malik dump. You take size T and a char star. Let me say mem list head, and then we say wow. Null. Do the callback, and then we do M next. Okay. Put that into the header. If we if-def this stuff out, we can still call this function and it'll just never return anything. So now we go to main. Where do we have our debug printing? Must be around here somewhere. Logistics debug render. Oh, here it is. So we get to here. Looks like print keeps track of the line for us. So let's just always do it for now. It's going to be slow though. Dump memory. If dump memory void. We get a callback function void. Callback size t info. We need an sdict. Mem stats. We need a typed up struct. Info size t total size t largest size t count stats. Oh, we call that that. Naming things so hard. Which one of these gets to be called mem stats? Stats s equals has to be sdict get info. This is null. That'll be annoying, so let's just go ahead and do it. You have to say which dictionary you want. And stats table. Info ms. False. All right. So when we want that memory, we say sb sdict new. At the end, we'll sb sdict free. Destroy. I think it's free. Stats. Okay. I guess we could keep that one around and recycle it instead of having to do this every frame. OBBG malloc dump callback. Now we need to go through every item. There's some kind of sdict loop that I don't remember how to use. So has to be sdict for the dictionary, an integer variable, the key, and the pointer. Excuse me. And then we Well, let's just print it for now. We want to sort it actually, but right. Body 80. And that is count info largest total largest info. Let's see how that goes. See if anybody's. I have some kinds of autocomplete, and I have some kinds of coloring, obviously. See if anybody's. I have some kinds of autocomplete, and I have some kinds of coloring, obviously. I can't actually leave this cut and pasted here. This needs to be a pointer. And this was cut and pasted in. Okay. Function incompatible types. Oh, void and int. All right. Void. Okay, what is it called? Oh, I'm right on it. New. Do I call it destroy? Delete. Okay. To go with new, I called it delete. Dun, 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 dun. Why does that? What did I say that took as parameters? Size, info. Oh. Right. Size, info. Dump callback. Size. I can't actually leave this cut and pasted here. Coloring, obviously. I can't actually leave it. I have some kinds of autocomplete, and I have some kinds of coloring, obviously. I can't actually leave this cut and pasted here. Size, info. Okay, right. The type def does not need to have the. The type def does not need to have the asterisk in it, which simplifies life a lot. Because if you do put the asterisk in, it gets confusing. Okay, there you go. Now we have a bunch of stats. They are not. Okay, there you go. And it gets confusing. Okay, there you go. Now we have a bunch of stats. They are not spaced correctly, and it's not sorting them. And they're unstable too, so even if you did sort them. I guess as long as you sort them by size. Alright. So we need to sort them. And we can do that very easily. We will just make another table, and we can do that very easily. We need to sort them, and we can do that very easily. We will just make another table, mem stats. Make it an array, an std array, our push array of s. And then I don't know what we're going to do with the spacing. We need a space character that's the same width as a 0, as a digit. And I guess we can do that as a hack for now. And then qsort We want to sort the array. Number of elements, so it's not SB array on. Oh, I'm using SB array here. That's fine. Let's use SB array here. So it doesn't go through the memory tracking system and mess things up. So the number of elements in the array, the size of the elements in the array, and the sort function. And we're going to sort on total. So we use std int comp, which takes offset of memstats, comma, size. Dunk. I think that's right. That's actually an assigned int. What was total? Let me check if I have a uint compare. I don't know if I do. Might. Nope, I don't. Too many friends. So I just started typing them at the end there. Alright, here we go. It's gonna work. It's gonna be magic. It's sorting them in the wrong order. Sorting them in the opposite order of what I want. And I have to actually no. Alright. Let's see. Let's see. Alright. Let's see. Hello? I guess I didn't hit F5. Okay. Unreadable because of all the zeros. So I want to do something to improve that. Not enough digits. The 1, 2, 3, 4, 5, 6, 7, 8. It claims to have 2.8 gigabytes allocated to map gen chunk, which I do not think is true, because I have more than this is a 32-bit thing, so I can't have 3 gigabytes allocated. 1, 2, 3, 4, 5, 6. No, I'm misreading it. Okay. I would really like to have commas in those. 293 6113. Yeah, okay, good. It's only 9 digits. So let's bump that to 9. Alright, so we can see map gen chunk going up. I don't think it should. I don't think there should be that many gen chunks out. Unless the gen chunks are the tiny things. But they're not. They're huge. You can see it's saying there's always 272 gen chunks around us, and that's how many are allocated. But those should be stored as meshes, not as gen chunks, I think. I'm going to have to look back through how this whole system works. So then you have the worker vertex buffer, worker face buffer. Those are just allocated one per thread. You can see there's only 3 of them. That's never going to change. Okay, I got to do something about these leading zeros and stuff. That's just too confusing. What's a good way to do this? I'm just going to have to write a new print routine. So what does print do? I'm just going to have to write a new print routine. So what does print do? Okay, I got to do something about these leading zeros. Okay, I got to do something about these leading zeros and stuff. That's just too confusing. What's a good way to do this? I'm just going to have to write a new print routine. So what does print do? Print string takes an explicit address. Okay, so that's what we want to use. So print column, and then just take it to raw string, and then this we'll call print string. And we'll go ahead and use this pos.y stuff. So print string, some X, pos Y, stir, and whatever color we're using up here, text color. And this will take an integer index, and then equals so if ID is greater than equal 1 and ID is less than equal 3, then do we have a way to get the width? Is this just calling easy font? Yes, it's just calling easy font. SDB easy font width stir. Is this a float or an int? Float. I have no idea what the correct spacing for these here, so we'll do that to start. We subtract it in this one. So now we say print column. Printf. Column 0. Column 1. Column 3. And then we call print of nothing to do the new line. Did I mistype a sprintf? Does Windows printf support %d? Does Windows printf support %d? Probably not, but I can check. Okay, and look, I got the spacing was all wrong. If it doesn't, I'm just going to write my own. It may be that they support now, but the VC6 doesn't. It's too old, also. Oh, I still didn't get it right. Oh. Did I mistype a sprintf? Does Windows printf support %d? Probably not, but I can check. Okay, and look, I got the spacing was all wrong. All wrong. And look, I got the spacing was all. I can check. Okay, and look, I got the spacing was all wrong. If it doesn't, I'm just going to write my own. It may be that they support now, but the PC6 doesn't. It's too old, also. Oh, I still didn't get it right. Oh. Weird. And I hit a bug somehow. Am I doing something wrong? Is my coordinate system just totally off? Oh, this wants to be 0 on. Let's do that. I'm just trying. Might need to go before. I'm just trying. Might need to go before the number also. Nope, no luck. Okay, now it looks like the spacing is way too wide. All right. Don't know why Gen Chunk and Mesh Chunk are so different. 1, 2, 3, 4, 5, 6, 2, 6, 8. So we're not using that much memory. Using this. I should show the total amount of memory. And then if we start flying, does anything leak? But I'll switch it to the long view. We're not using that much memory because we have the short view set up. Looks like something momentarily uses a lot of memory and pumps up on the list, but doesn't show up that often. Oh, Mesh Chunk did come back up. Interesting. But yeah, it looks like that Gen Chunk stuff is leaking. I mean, I could be wrong. Maybe that's... No, because the physics chunks get stored differently. You can see how much they're using there, 400K. So yeah, the map gen chunks seem the most likely culprit. But one interesting thing here is I didn't truncate this list. These are all the allocations in the system. I mean, there were a couple of them that are allocated in multiple places. But this is one of the reasons why we talk about that memory management just isn't that big a deal. Is that, like, there just aren't that many things, different things being allocated to worry about. All right, well, let's go ahead and bump the view distance. Which I think is that these days. And I'll add the comments if this is unreadable. Yeah, and this is where I was saying, gosh, it's really slow to pop in. It takes forever to build the distant stuff. Don't know why. That'll be the next thing we'll look at when I get this memory stuff settled. So the mesh chunks should just keep growing and growing because there should be a lot of mesh chunks. As you can see, they're not that big. I mean, they're not tiny either, 16K each, but it does look like it's way ahead of the gen chunks now this time. So maybe the gen chunks is correct in some way that I don't understand. I just have to go look at what the gen chunks are for, who would keep them around. Maybe that's just how big the cache is. Maybe I have a gen cache chunk that's 16 by 16. So it's 256 gen cache entries. That's probably it. I guess I should run a release so it builds out faster. That's a lot of gen chunks, though. It's a lot of temporary stuff being created on the fly. Like, you shouldn't probably have that much work outstanding. It should never get that far ahead of 256, I don't think. The question is, will it settle down to 256 if I just sit here? Oh god, anything that depends on locale, like, which is everything. The locale system is such a... Oh god, anything that depends on locale, like, which is everything. The locale system is such a mess. So, and it's not including the memory to actually store the OpenGL mesh data in this, because that's invisible to us. But that is something that is competing for memory, and could be contributing fragmentation. Turning on the AC. Turning on the AC. Oh yeah, I should take my pills. Let me know if the AC is too noisy. Let's see, how are we doing here? Gen chunk's still high. That was still generating Q chunks. The worker threads in mesh build started is just wrong. It's just not seeing them. It's due to the threading. I have to fix that. So now you really have a ton of mesh chunks. It's so slow to build all that now. Something did get broken at some point. Okay, Q chunks has stopped going up. The valid in and range numbers, so it should have stopped building. BBuff storage claims to be using about 566 megs. And Gen chunk is not going back down. So maybe there is a Gen chunk leak. That would seem likely. I mean, I thought that at some point. That's why there's a separate thing outputting the number of Gen chunks. But at the time, I didn't conclude anything about it. And we just ran out of memory. No, we hit a bad chunk in our malloc list. No, we hit a... And we just ran out of memory. No, we hit a bad chunk in our malloc list. Whoops. Yeah, I hit this before and I just was like, that's not good. So M is garbage, so we want to step back one. Unfortunately, there are so many memory items. Oh, right. Well, we're running in debug. That's why stuff was slow. Who knows how it would be in release. I can't step back, though, because memlist head, who knows how far down memlist head it's bad. And memlist head is currently commented to 0. Yeah. So I can't call check mem. That's unfortunate. We're just gonna have to get a trigger again. What was it? F-E-E-E? F-E-E-E? Why is the frame rate so unstable? Let's take a look. Why is the frame rate so unstable? Let's take a look. I mean, I'm in a debug build, but it doesn't necessarily mean anything. Well, okay, so it's V-syncing, and however it's clocking the V-sync is not hitting 16 exactly for some reason. You can see the render time is really inconsistent. That could be the clock that I'm measuring it with, or it might just be inconsistent because the GPU is inconsistent. It could be that the GPU is clocking up and clocking down or something like that. The frame time actually doesn't look like it's VSyncing. I thought it was, but... And I changed it at the beginning of the stream to try to force VSync on. Let me try doing it in the driver. Yes, he is what? I don't even know what you're... Why did that never show up? Yes, he is what? I don't even know what you're... Yes, he is what? I don't even know what you're... Why did that never show up? Just like NVIDIA control panel refused to run if you're on OBS open. Let me do something else for a second. Just want to check my mail. And I forgot to move it off the screen first. Okay. Oh, nothing important. Well, so for some reason I can't open NVIDIA control panel. So I can't fix that. Very odd. Don't know what it's doing. NVIDIA control panel. Very odd. Do I even have that installed? I thought I uninstalled that. I don't have arrow on though. I don't have arrow on though. I can't even shift control escape. There it goes. Do I have something eating the CPU? OBS. There. GeForce Experience. Good. Okay. I did uninstall that. I just didn't get it all. Firefox. Do I have a Firefox running? Oh, yeah. All right. I have Twitch open to read the chat. No, I don't see anything. See anything weird there. I don't know. I don't know why the frame rate's unstable. I don't have arrow on though. I can't even shift control escape. There it goes. Do I have something eating the CPU? OBS. There. GeForce Experience. Good. Okay. I did uninstall that. I just didn't get it all. Firefox. Do I have a Firefox running? Oh, yeah. All right. I have Twitch open to read the chat. No, I don't see anything. See anything weird there. I don't know. I don't know why the frame rate's unstable. I don't know why the VSync isn't happening. So yeah, let's see if we can retrigger this. Failure. I don't know what it takes to do it though. It happened really early the first time. And we just ran out of memory. No, we hit a bad chunk in memory. No, we hit a memory. So yeah, let's see if we can retrigger this failure. I I don't know what it takes to do it, though. It happened really early the first time. Oh, it messes with the Windows ability to vsync properly. Yeah, I don't know, maybe. It could be. Oh, it messes with the Windows ability to vsync properly. Yeah, I don't know, maybe. It could be. Alright, good. We hit that spot. Oh, I have P up here. P was garbage. Great. So it was already garbage before we got that. Before we crash. So anybody got any questions while I'm mindlessly driving around trying to trigger a bug? There, I'll leave up the answer to the Minecraft question. Am I planning on making it into a full game? Am I planning on making it into a full game? It's all kind of unclear. The main thing right now is that I started adding a sort of Factorio simulation system with machines and stuff moving around on conveyor belts, which is the current direction the game part of it is going. Okay, so M is garbage, and P is garbage of a different kind. And we have to restart. Wait, that happened right at the beginning? Or had it not restarted? Must have not restarted. Okay. So here's the Factorio sim. At some point I need to go through and have twice as many frames for these curved things. They don't look very good. And here you can watch some things go down and screw up a little bit because that's a bug I introduced at some point and never fixed. Because I want to move on to other tasks. We're just transitioning to the wrong part of this belt or something. Oh, and they're getting stuck here. Yay, bugs. All kind of factorial belts, which is the current direction the game part of it is going. Okay, so M is garbage. Okay, so M is garbage. And P is garbage of a different kind. And we have to restart. Do they never come around on the other side at this point? Are they never dense enough on the other side? I guess they're not. So who knows what I broke there. They used to come up onto here. Alright, let's see if we can set off the bug. What we need more of is science. What we need more of is science. Now that's really noisy. Did I turn off MSAA? The stuff in the distance is aliasing to crap. I could be with MSAA though. Maybe I never... No. Maybe when I switched to SDL. I don't remember if I did the original demo with SDL or not. And of course now it's not fucking crashing. Excuse my language. Come on, you can do it. You can crash. Please crash. Oh, and we can look and see how much memory got used for all the logistics stuff, because even though that stuff is chunked, it's still keeping it all loaded. So you can see 1K for the the list of all the different belt runs, and then the list of ores is taking up about 1K as well. $164 bytes for the machines, 132 bytes for the pickers. The ore list was a temp thing. So you can see how that logic stuff is designed to scale. The logic chunk is the biggest piece. Because there's some fixed arrays in that or something. I don't remember now. So you could easily have, 16 megs would be 1,000 logic chunks. So you could have a factory over 1,000 logic chunks, still have it all loaded in memory, only 16 megs. Well, this is sucking that it's not crashing. Our gen chunks is up into the 500s. And it hasn't crashed. I guess we start over. Now, it's also possible that there's something not being marked up properly that I'm not measuring in the mallocs, but I think it's unlikely. Whoop. The physics on the camera blew up for some reason. Or do distant chunk gen performance be related to the mutex? Or do distant chunk gen performance be related to the mutex? Which mutex? The ID changing between. Don't know what you mean. Try not moving. Not moving. Try not moving. Try not moving. Was I not moving when it happened before? One time I was definitely moving when it happened before. But maybe another time it wasn't. Still slowly building G-chunks. Yeah, I don't think the position of the camera is going to matter. Yeah, I don't think the position of the camera is going to matter. That shouldn't feed into the generation. Like something in the what the generating is mallocing and freeing and overlaying memory. The renderer is never going to do that. I mean, never say never, but highly unlikely. I don't know. That's going to be really frustrating if it keeps happening, but I can't reproduce it to debug it. But these gen chunks definitely seem to. Yeah, I don't think the position of the camera is going to matter. Chunks definitely seem to be going out of control, so that is the next thing I should do. I'm going to check this in and then do that. But I can check it in while it's running. To debug it. But these gen chunks definitely seem to be going out of control, so that is the next thing I should do. I'm going to check this in and then do that. But I can check it in while it's running. I'm going to check this in and then do that. But I can check it in while it's running. What is task list? Oh, okay. That off. Sorry, I was looking at release gen chunkiness and mutex lock is used. Sorry, I was looking at release gen chunkiness and mutex lock is used using a global ref count mutex. Thought maybe somehow ref count mutex was changing between lock and unlock, causing delays. Is the map generated using the same seed? It is currently, like, that's just not a priority right now. Alright, I don't know. I can't reproduce it. I just gotta look at what's going on with gen chunks now. And I just hope. Alright, I don't know. I can't. Alright, I don't know. I can't reproduce it. I just gotta look at what's going on with gen chunks now. And I just hope next time we hit it, it'll be debuggable. Map gen. Wait, it was gen chunk, right? Yeah. Okay, so gen chunks. What are gen chunks used for? Are they in a header file? No, they're right here. Gen chunk contains all of the data at full size for an entire chunk, which is 32 bits per vertex per voxel. So 4 bytes per voxel, and the gen chunk is size-wise. Gen chunk size is going to be in his. Gen chunk size is 2 to the 5, 32. So it's 4 bytes times 32 times 32 times the height. So each gen chunk is 1 megabyte. And it's supposed to be the temporary data that's used for generating mesh chunks. So then how big is the cache? 16 by 16. So it's going to always be using 256K plus whatever extra temporary ones are in flight. Why are there temporary ones in flight? Well, we get a ref count. And you get something out of the cache, you up its ref count, and now it can get freed from the cache, potentially out from under you, and you'll still have a valid copy of it in your ref count. Once everything stops building, it should go down to 256 gen chunks, the ones in the cache. And any things that aren't in the cache, we can look at their ref counts, especially the augmented ref count, which was exactly to debug this. I started this at some point. Don't know what happened to it. Right, we keep track of in what mode it was ref counted. So, let's monitor create. Aha. We have a global table tracking them all. There we go. That's exactly what we need for this. Track allocated. And we have it turned on. Okay, so I was trying to debug this at some point and never finished. Which is actually going to slow things down a little bit, but probably not that much. So now we say void monitor now we say void monitor examine outstanding gen chunks. So we can iterate over all of them. What is monitor ref count doing? We're about to touch the ref count and we make sure it's present. I think was the intent. Right, so this is sort of here. That's the reason for this code. Okay, so we loop over all of them. And now we loop over its ref counts. So what? It's augmented ref count. So we assert the arrow ref. Oh, we assert that its ref count is non-zero. Then we say if its augmented ref count. Well, let's do this. Int cache count. If it's augmented ref count for being in the cache, I don't know what variables do we use for that to index that. These ref cache. So we count the ones in the cache, and then the ones not in the cache. Output what's the range of that? Count. If GC augmented rough count. Well, let's just print them. Print. J. That's ODS. Print. ODS new line. ODS. Cache. Cash count. Okay. And then that goes in the header file. Examine outstanding gen chunks, and now we want a key to trigger that. Dun 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 ba dum bum 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 bum. SDL scan code. Are we using C for anything? Doesn't look like it. What was that function called? Examine outstanding gen chunks. All right. All right. Let's leave it looking at the factory. So even now, it's maybe questionable. So let's go ahead and do that. C. Oops. Plug in my code. Oh, I left in that. All right. So let's look at this. The output of this stuff. Oh, this is going through the SDL. Let's not go through the SDL. So it's probably in main. What do you do for Win32? I don't remember. So it's probably in main. So it's probably in main. What do you do for Win32? I don't remember. Okay, underscore. Together. Oh, that's redundant too. What's in the overview? That's redundant too. What's in the overview? 320 chunks? Wait, didn't I print how many cached ones there are? I thought I did that. Num in cache. Why did that not print? Anyway, they all have the last type. What's the last one? Mesh chunk status. What is mesh chunk status? Oh, there's a mesh chunk status, and that's its own cache. Mesh status 64 by 64. But it shouldn't keep things alive on its own. And maybe it is. Maybe that's the bug. But why did it not print that other thing? Did I not put a new line at the end? No, there's a new line at the end. Why did that not print? Yeah, you are allowed to update the ref count without being in the ref count mutex, maybe? I don't think you're allowed to. Oh, but you don't get deleted at the same time. So yeah, you can be an invalid one in there. The map is being generated. The map is being generated. The only thing that's saved is the factory updates, which are edits to the map. It's just saved out the edits, not the whole map. It does regenerate it from scratch. Because it generates reasonably fast, so it's not a big deal to wait for it to generate the local region. Okay, so then hit C. Num in cache 256. All right, what we expected. All right, so it seems like they're accumulating in the mesh chunk status. So I need to look at that logic. I don't know why it's not printing the final data. The debug output is flaky. 2. Some of them are showing up in 2 statuses. All right. So the mesh chunk status, I know what its job is. I just don't know. All right. So the mesh chunk status. All right. So the mesh chunk status, I know what its job is. I just don't know how its lifetime works. So the mesh chunk status, you abandon it, you release the gen chunks, set the status to invalid, and the releasing the gen chunk would free the ref count. So when do we abandon? We only abandon if a new mesh status falls in an old one. Okay, what do we do when we kill an old task? Maybe we don't ever kill it. Interesting. If we start something and then decide we don't want it after all, because the priorities have shifted. All right. So the mesh chunk status, I know what its job is. I just don't. So the mesh chunk status, I know what its job is. I just don't know how its lifetime works. So the mesh chunk status, you abandon it, you release the gen chunks, set the status to invalid, and the releasing the gen chunk would free the ref count. So when do we abandon? We only abandon if a new mesh status falls in an old one. Okay, what do we do when we kill an old task? Maybe we don't ever kill it. Interesting. If we start something and then decide we don't want it after all, because the priorities have shifted, it might be that we never abandon it. And so I'm writing all this code on the assumption that that's what's going on without even checking. Because I don't see a similar function yet. Okay, so abandon mesh chunk status sets it to invalid, blah, 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 freeze those things. Okay. And so I'm writing all this code on the assumption that that's what's going on without even checking. Because I don't see a similar function yet. Okay, so abandon mesh chunk status sets it to invalid, blah, 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 freeze those things. Okay. So now, how do we decide to abandon a mesh chunk? Well, somewhere we go through the list of requests. Somewhere we process a list of requests. Somewhere. Get next task. Delete any requests that are already in the mesh building stage by rebuilding a list in place. Right, we delete it from the list, but we don't ever deactivate it right here. Oh no, wait, that's not it. We delete it on the list because it's already processing and we don't need anything. And here we do that. And we don't take any look at things that we currently have processing. Oh, here it is. Oh, we try to call abandoned mesh chunk status. We do. Why are we iterating over it? Max built meshes. What is that? Most recent renderer meshes. What is any of this? What is this? Okay, I obviously tried to do this already. Oh, these are the lists we swap between. Okay, when we swap meshes, most recent renderer meshes gets empty meshes. Empty meshes get temps. Renderer meshes gets true. Yeah, see, we're doing a three-way swap now, so I don't know that that's... Oh no, it's a two-way swap and a two-way swap, I see. Swap current processing. Most recent renderer meshes gets current processing meshes. Okay, so that was the set we asked for last frame. Alright, so let's look at this again. So it is trying to do it already. It calls get chunk status. Why is it called get chunk status? Right, so right here is supposed to be doing it. Yeah, okay, right. All makes sense. Ones we requested, boom. Ones we requested last frame, but we didn't request this frame, we tried to delete. Is there some third case? What case would miss these cases? If it's even older, we could miss it, but we should have hit it the previous iteration. What's the MCS in new list? Oh, that's this. Let me set these flags. Do we ever clear them? Yeah, we clear them here. Yeah, no, it looks like I tried to handle all this. The issue is going to be if there are MCSs out there that for some reason aren't in either of these lists. So if it got started 2 frames ago, if it was on the list 2 frames ago, but it's not on last frame's list, we would miss it here. But last frame, we should have already removed it. Alright, let's do something a little more brute force. Alright, so first of all, mesh chunk status. Are they only in... Let's do something a little more brute force. Alright, let's do something a little more... Alright, let's do something a little more brute force. Alright, so first of all, mesh chunk status. Are they only in the cache? Do we never allocate them other? Yes, because notice that's not a pointer. It's directly stored in that. Okay, so we can iterate over all of them explicitly. So let's do this. Because I don't know why the current code doesn't work. Let's just solve it the different way. So, for I equals 0, I less than, what was that called? Mesh status x. And then we say MCS in new list equals false. Boom. Now, instead of going through the whole list, we just go through all of them. Oh wait, it's times 2, isn't it? Yep, sub 2. What was I? If mesh status well, equals false is pretty dumb. Then we want to discard it. Abandon mesh chunk status of all right. A little expensive. We're looping over 64 times 64 things, kind of needlessly, but or times 2. But we'll see. And we don't need that new function that I started to write because we're just calling the old one. Body in the first loop isn't using I. Did I just... Body in the first loop isn't using I. Did I just fix that? Yep, I just fixed that. Okay, we tried to freeze something out that was still active, so we abandoned it while it was still processing. So the thing is if the mesh status except it has to, let's see what that was again. Oh, we gotta think more carefully. MTS status, chunk status processing. So once we get to the status processing, wait, it was neither processing nor, what was its status? 0. What's chunk status 0? Invalid. Yeah. We're not allowed to abandon it once it's started, I think, is the rule. But we're always allowed to abandon it because it's... Aren't we always allowed to abandon it if the cache thing hits? Where do we call abandon? Here. If we try to get something, we only call abandon if it's in the non-empty state. Why do we not call abandon if it's in the empty state? Because if it's in the empty state, there's no work to do, so it doesn't matter. The main thing is we don't want to call it when it's in the invalid state, probably. Although I think there's something subtler here. I don't think that's going to change anything. I think I have to actually pay more attention to what the state machine for mesh status is. It's possible, but if this doesn't work, it's possible there's just always been a lurking bug that if you tried to reuse the slot, there was going to be a problem. Yeah, I think so. All right, so we're doing this inside the mutex, but somebody could right now actively be handling that one. And they need that mesh status to stay valid since they're actively handling it. Okay, rather than understand what's going on, we're just going to add a new status. Chunk status dying. This. Just going to add a new status. Understand what's going on. Okay, rather than understand what's going on, we're just going to add a new status. Chunk status dying. Maybe it's just if it's processing, I need to do something special. Let's try that first before I go into this dying mess. Let's try that first before if it's processing, I need to do something special. Maybe it's just if it's processing, I need to do. Maybe it's just if it's Maybe it's just if it's processing, I need to do something special. Let's try that first before I go into this dying mess. Maybe that is the right state machine state. Maybe that is the right state machine state. Nope. Okay, so the problem is that, I mean, I don't know that this is what's happening, but some other thread is using that. So I can't kill it from this thread. Presumably. In fact, here we're not even inside a lock when we get these. We assume we don't need to be in the lock to get these. No, we are. We're inside a bigger lock. Manager mutex. Okay. We get the MCS inside here. Mesh is being rebuilt. I have to invalidate all of those. Okay. If its status is processing, then who sets its status to processing? Yeah, when it goes to processing, we've already actually taken away all the chunk data, so there's nothing in there. So processing, it's okay to kill. We don't actually look at the MCS ever again once we hit that. And this one is the physics processing, I think. Yeah, build phys chunk. We set its state to processing once we're done with it. So processing is always safe. Once we start building it, we set its non-empty chunk set status. We add a ref count for the chunk. And here's where we actually start a task. Go to found task. Boom, we're done. So if we find a task, we return from the get next task. And we start doing the task. And we don't care about the mesh status at this point anymore. We're not going to touch the mesh status. Yep. We only ever touch the mesh status inside the manager mutex. It just doesn't care here. So... and we're doing all this updating inside the manager mutex as well. So why is it bad to kill it here? Maybe it's just the processing assert that's wrong. Maybe this is no longer true. We finished caching a mesh chunk. If it's the right one, it should never be invalid. If we invalidated it, it should have killed the X and Y, and that's probably what's not happening. If we invalidated it, it should have killed the X and Y. And that's probably what's not happening. If it's the right one, it should never be invalid. If we invalidated it, it should have killed the X and Y. And that's probably what's not happening. Wait, these are chunk counts, so it has to actually be the way to set this is non-obvious. We don't have the information available. Okay, it still claimed this MCS fit. Chunk X -2. Yep, that sure looks like the right one. And its status is not chunk status processing. It is now 2. Just some other chunk status. Which implies that it restarted this, probably. It restarted the same chunk it was already doing, which is why we keep it alive. Also, I'm not moving, so I don't know why it would change. Why it's not still in the set. Oh, what's going on here? I don't understand this code. It is the freaking multi-threaded mesh building nightmare that is always the source of all of my problems in this code base. Probably if I knew how this worked, it wouldn't be that big a deal, but I've forgotten the details of exactly how this works. Why does it need to keep the chunk status processing? Right, we wanted to keep chunk status processing so that we would never try to rebuild this mesh while it was already building. So we have to keep it around. So the moment it starts processing, we want to keep it around. So if it's processing, we don't want to kill it. But we don't. We already have that in there. Oh, no, wait. We have this. Right. So if it's processing, we don't want to kill it. So if it's processing, we don't want to kill it. But we don't. We already have that in there. Oh, no, wait. We have this. Right. Oops. Status. status. Status processing. Alright. Maybe? At this point I've changed a bunch of stuff to the point that I don't actually know what it's doing anymore. Did I leave some debugging-y change? I temporarily, I'll just change this for a second. Did I leave one of those in? Quite possibly. Alright. Our gen chunks. See if it never goes up too high now. Is this running while I'm doing this? Yeah, okay. Not p4 diff, git diff. Jump. Temporarily, I'll just change this for a second. Did I leave one of those in? Quite possibly. Leave one of those in? Quite possibly. Possibly. Alright. Our gen chunks. See if it never goes up too high now. Is this running while I'm doing this? Yeah, okay. Not p4 diff, git diff. Jump. Sure. Doesn't matter. Sure. Do that. Right, we made this change to the old code, which was wrong, but it didn't have the chunk status processing. So it might be that we could go back to the old code and the MCS status chunk processing. So we can try that too. Hey look, our gen chunks is still staying down near 256. Yay! We fixed a kind of memory leak. It was bounded in how big it could be, but 64 by 64 is pretty big. 64 by 64 is 4K. And I think it might have been able to cache 4 by 4 in each one. So it might have been able to inappropriately keep around 16,000 gen chunks, maybe? Possibly. Maybe it would have to be slightly fewer. Alright, so I bet that was it. We still have an unknown crash bug that we don't know how to reproduce. Well, there you go. It seems to be staying pretty close to 256. Hooray. Alright. Just for fun, let's try putting it back to the old thing and see if that extra test did in fact fix it. What was the thing I tried to start to add? The dying. Because this one doesn't have to loop over 4,000 items to find the ones to kill. So if this also works. Nope, this looks like it's still going to go up. Alright, well, don't know why the old logic doesn't work. We'll switch to the new logic for now. Iterating over 4,000 things a frame isn't that big a deal. But it would be nice to know why. And yeah, I'm going to take a break. Was waiting for a good breaking point, and this is probably a good breaking point. And I'm going to stop and restart the stream so the YouTube archive gets split, and so the annotations don't get too long. Alright, so let's put it back. There it is. And yeah, I'm going to take a break. Was waiting for a good breaking point, and this is probably a good breaking point. Breaking point. And I'm going to stop and restart the stream so the alright, so let's put it back. Alright, so let's put it back. There's that is fix gen chunk in a hacky way because we don't right way it's failing. And I will go ahead and push that. All right. All right. And we will stop there. And I will be back in, let's say, half an hour or 45 minutes, something like that. Please do feel free to come back and return, and we will move on to performance profiling. I think that's what's up next. So, all right. So see you in a bit.